The following is a production of New Mexico State University.
To many of us, arid means desert, wasteland. We think of sand, endless sand, with perhaps a few cactus or a tumbleweed. But once you let your eyes become accustomed to it, you can find incredible beauty and diversity in arid and semi-arid landscapes. Grasses unlike any you've ever mowed, trees with leaves shimmering in the sun, and roots drinking deep from underground streams. Creatures large, creatures small, birds whose songs travel far on the wide wind. Within these fragile ecosystems, the line between life and death is easily crossed. The rules are different here in ways we don't entirely understand. Like the sea, the desert hides more than it reveals. Are we losing? Have we already lost something irreplaceable? What are the secrets of living in harmony with nature in these wild, unpredictable places? What we learn and what we do with our knowledge will determine our ability to be survivors in the sand. Today, when this train pulls out of Alice Springs in the Northern Territory of Australia, it's loaded with tourists eager for a taste of history. It wasn't until 1929 that the railroad penetrated this deep into the outback. Alice Springs was still a dusty frontier town. The railroad was a thin lifeline that promised survival to the miners and ranchers in the hot red center of Australia. Throughout history and around the world, people have been drawn to these arid open spaces. What was once a trickle of migration has gained momentum over the past century. Whatever their mode of transportation, the influx of outsiders into these lean landscapes has set in motion a wave of change that reverberates today around the globe. There is no one profile which fits all arid lands. Some are dry and frigid. Some have scorching heat year-round. Although definitions vary, many say a desert is any region which receives less than 10 inches of precipitation a year. It may come scattered throughout the year, or all at once. Droughts, which may last for years, are the rule, not the exception. Over 20% of the Earth's land surface is classified as arid or semi-arid. Match that with a global population expected to double within only 40 years, and the threat to our planet's remaining open spaces comes into focus. They comprise a land bank, a reserve for the future. We are depleting this reserve. The effects of agriculture, urbanization, mining, and tourism are already visible. If it is mismanaged, arid land quickly loses its ability to support life, human or otherwise. This degradation, called desertification, is a very real phenomenon. Experts say we're losing 15 million acres of productive land every year on a global basis. In the next hour, we'll visit 3 of the Earth's foremost semi-arid regions, where scientists are working to halt desertification and unlock the secrets of this land before it is too late. In the Australian outback, the land is so vast that scientists have taken to the sky to get perspective on the changes wrought by Europeans in the past 170 years. They hope what they learn will help people like Robin Cadzo repair the damage done by past mistakes and cope with this extreme environment.
You can't work against Mother Nature. You have to work with her and perhaps enhance it.
In the southwestern United States, the population shift to the Sunbelt has created some unlikely partners in the battle to preserve open spaces and keep this fellow alive. We'll meet Matt McGuffin, rancher and savior of the Chihuahuan leopard frog.
If we don't do something soon, all the open spaces are going to disappear, and then everything will be endangered, including people.
In Israel, massive effort has gone into a campaign to restore some of the green that was lost from this landscape over the centuries. In just 50 years, startling changes have been wrought. New technologies are bringing life to once barren land.
Deserts are what you make of them. When you look around here, every tree and every flower, every bush we've planted ourselves. It was really just sand. And what you put into it is what you get out of it.
Australia, the United States, Israel. All are struggling with issues common to arid lands everywhere. But each faces unique challenges shaped by geography, climate, economy, politics, and social values. How much and how quickly can we learn from the desert and each other?
We must learn from the ancient inhabitants of the land, not necessarily the people that inhabited the land, but the plants and animals that live on this land. That the secret of their survival, the secret of their persistence, is the ability to use the resources in a sustainable manner, to use the resources that they can be renewed.
Uriel Safriel is a leading Israeli ecologist with an international reputation in the study of arid lands. Along with others, soil scientists, desert ecologists, hydrologists, botanists, and animal physiologists, he's worked to build a body of knowledge that will allow man to manage without damage for the good of all.
Especially when we are going to develop marginal areas that are very sensitive to interferences, that are very delicate, very sensitive to changes. It is very important that we know what is the right prescription for their development, so that anything that we do to these areas is not jeopardizing future uses of them. And this is actually the goal of our research.
What they learn, they share with other nations with similar geography and climate. While managing arid lands may be a growing international problem, it is certainly not a new one. At least 40,000 years ago, Aboriginal tribes roamed the vast dry center of Australia. Drawings etched and painted on stone tell stories of lives spent hunting and gathering. The Aborigines survived by moving into the desert in good times, back to reliable waterholes in times of drought. They used fires for signaling and clearing brush while hunting. This produced a mosaic of patches in the landscape, which increased the diversity of vegetation and ensured that wildfires ignited by lightning would never burn very far. In the San Juan Basin of northwestern New Mexico, ruins tell the story of another desert people, the Anasazi, who lived here between 200 and 1300 AD. They gave up wandering and settled in the fertile canyon, building 5-story houses of stone with hundreds of rooms, dwellings for thousands of people. The Anasazi installed irrigation systems to support extensive agriculture. For 1,000 years, the Anasazi lived and worshipped here in the desert. But by 1300, these pueblos were abruptly abandoned. Some evidence suggests a long drought, but no one knows for sure. There are mysteries, too, buried in the sands of the Middle East. This part of the world has a long tradition of survival in the sand upon which to draw. The Fertile Crescent was, after all, the cradle of civilization, but survival was by no means guaranteed. This is Sucia, a Hebrew city built in the 4th century AD. At its peak, Sucia had a population estimated to be around 10,000. Archaeologists have reclaimed from the sand a synagogue with elaborate pillars and beautiful mosaic flooring. There is ample evidence the residents used the technology of their day to adapt to their harsh environment. Here, in the desert, the inhabitants of Sucia grazed livestock on desert grasses. They raised grapes for wine and pressed olives into oil. An elaborate system of ditches captured scarce rainwater and collected it in cisterns. Every house had its own canal system. Underground caves provided refuge from the hot sun and from invaders. No one really knows why Sucia was abandoned some 1,200 years ago. Today, it stands as silent testimony that here, in the desert, life has narrow margins. Subsistence is hard won.
If you go back to the Bible, it was mentioned that in this area there were woods and trees and greens and pasture, and Abraham was in Beersheba, and flocks, and people were living. And if you go back in a later period, we go to the Nabateans. Nabateans have very large towns here. The people lived in this desert. What happened is that, like we say, during the last 7-8 centuries, as a result of overgrazing, mismanagement, erosion, which happened as a result of mismanagement, all this area was transformed in a desert.
David Mathias is a leader in the development of strategies and technologies for sustainable, ecologically sound management of arid lands. Much of this work centers on finding the most efficient ways to use the scarcest resource, water.
We have politics, and we have wars, and we have this, and we have that. I believe these things we can deal, politicians can deal. But the true essence of the life of Israel is how the people will live in the desert. I don't want to use big words, conquer the desert. I don't want to conquer the desert. How we can live in the desert, with the desert, and have the best symbiosis possible. And this is the main problem of Israel, to my opinion.
Living, surviving, is central to the Jewish national psyche. After 2,000 years in exile and the horror of the Holocaust, the modern state of Israel was founded in 1948. It is a nation born in the desert, with its back to the wall, politically, geographically, and environmentally. Today, much of Israel is heavily urban. The population is concentrated along the Mediterranean coast. More than half of its territory, however, is comprised of the Negev Desert, which is home to less than 8% of the population. The Negev is the last major land reserve in Israel. Almost all of it is publicly owned. Given terrain many would have written off as barren, the Israelis were determined to make the most of what they have: sun and space. They set about learning how to harvest surface runoff water and control erosion. They built reservoirs and pipelines to capture and transport water, sunk wells in the desert, planted trees, and even trucked in soil for a new type of highly intensive desert agriculture. Entire new communities have sprung up in the desert. All this is testimony to what can be accomplished with a strong national will and heavy investment. Dramatic results, but at an enormous cost. Halfway around the globe sits another vast expanse of arid land, which will never be as developed as Israel. Here, in Australia, a single ranch can be as large as the entire Negev Desert. A continent and a country, Australia is nearly the size of the contiguous United States, while Israel is barely the size of Rhode Island. For the most part, the population of Australia hugs the coast. Fully 70% of the land is arid or semi-arid. It is a big sprawl of a place. Its center, a flat, ancient landmass. Iron content in the clay that's been mixed with sand for thousands of years gives the outback a reddish cast. Much of it is relatively infertile. Perhaps even more than in other deserts, the climate here is wildly unpredictable. It rains either too much or not at all. Mark Stafford Smith is an internationally known scientist captivated by this cryptic, improbable place.
Here in this riverbed we're sitting in, we had 10 inches of rain earlier this year, and it was flowing well over our heads where we're sitting. At the other extreme, we have to cope with very, very dry years. And a good way of looking at that is that the decade of the 1960s was our driest decade in the last 100 years, and it was under half the average rainfall of the decade of the 70s, which was our wettest decade for some years.
The bloom that follows rain in the desert is lavish, extravagant. Seeds sprout seemingly overnight. During droughts, which come often and last long, much of nature is programmed to shut down. This erratic pattern makes it difficult for ranchers, or station managers as they're called in Australia, to manage their herds and land. They have learned that to survive, they must plan for the worst.
You plan every year as if it's going to be a drought year. You have to think that you're not going to get any rain in summer, and alter your plans accordingly. And that's just basic management, station management.
Along with her father and brother, Robin Cadzo runs a 624,000-acre ranch or station. Here, in the Northern Territory of Australia, where 60% of the land is rangeland, conditions vary widely, even on a single station.
There's 88 different types of land here in Central Australia, and each one has to be managed totally different to the other. Just in one paddock, for instance, there could be 4 or 5 different types of land, and the cattle will always go to the sweetest, and therefore you've really got to watch that.
The danger is that the cattle will stress the best land past the point of recovery. Station managers have to read the land, watch the vegetation and cattle closely, and react, moving them to other pastures, or, if necessary, reducing the size of the herd. Sometimes they pipe water from wells out to farther pastures for the cattle, so overused areas around original water holes have time to recover. Faced with vast territory, limited resources, and unpredictable rainfall, Australian station managers work to restore small patches at a time. The techniques are simple and straightforward. Robin's family plows or pits the ground to create ditches that trap rain when it finally comes. Larger patches of green are created by ponding, building up embankments to trap water.
We shut the place up for 6 years, and we use this pitting technique as well as ponding, and the results are just absolutely dramatic. And we can actually run cattle in these paddocks now where we couldn't before.
Reversing the effects of desertification takes years. Deserts do not advance and retreat in a straight line.
I think a lot of people have this picture of advancing deserts where there's vast acres of sand, like this little patch here, sort of rolling across the landscape and expanding in some sort of tidal wave, as it were, into areas which had previously been in better condition. We really should have a much more complicated and harder to deal with idea of little pockets in the landscape gradually coalescing and becoming worse. We can't just look at it from satellite by just imagining that we've just got an edge which we've got to watch.
A variety of techniques to fight desertification are being used, some of them new, some not so new. Today, station managers and the government work together to burn small patches of land, an idea borrowed from the Aborigines. The burn releases nutrients into the soil, which sparks fresh grass and reduces the likelihood that wildfires will rage out of control. On a plot where the Israelis might spend $20 on reforestation, the Australians would have only a few cents to invest because their land is so vast and its productivity so limited.
We have to manage in a very different way. We have to firstly try and avoid problems in the first place, and where we do have to try and fix things up, we have to use techniques which are very broad scale and relatively cheap per unit area. How's the paddock layout around here?
Mark Stafford Smith is part of a team of researchers working with ranchers to promote better land practices.
It's more a matter of helping them make the decisions that they're making anyway better, perhaps making those decisions more regularly, and also helping them pass that information to other people.
Australian land managers have learned from the mistakes of the relatively recent past, such as overstocking, which degraded the land and depressed prices. But they've also had to cope with the after effects of changes introduced by the early European settlers.
If you had to ask what the single biggest mistake I think that was ever made in Australia, it would have been to introduce the rabbit. It was brought in just as a sporting thing, and indeed various other animals were brought in for similar reasons. It spread across the country, and there's no doubt that it was single-handedly was the biggest scourge. Not only did it eat vast amounts, it outcompeted some of our native mammals, and it's having an enormous effect on various plant species.
Buffalo grass, introduced into the outback for erosion control, has also gotten out of hand. Worldwide concern about the introduction of non-native plants and animals is growing. Unanticipated problems can develop. In Australia, station managers like Robin have begun to join forces to battle rabbits and non-native plants brought in from other countries. Through a new movement called land care, ranchers, or pastoralists as they're called here, are beginning to pool information and resources. But in this land where the nearest neighbor can be a day's drive away, cooperative ventures take seed slowly.
I think there is a bit of a pioneer attitude that persists on the rangelands, and particularly with pastoralists, and I think there's going to be quite a hurdle to overcome that mentality.
Environmentalists like Georgie Stewart and many scientists are interested in preserving biodiversity in the outback. They approach sustainability from an ecological perspective. For Robin and other pastoralists like her, it's more a question of economic survival.
A common misconception of people from the city to pastoralists and farmers is they think we're wrecking the country, and we can't really afford to do that because if we wreck the country, we haven't got a livelihood, therefore we can't eat. And they don't eat either.
In spite of their differing priorities, both agree that there's a great deal at stake in the fight against desertification. The issue of desertification is also very real in the American Southwest. These rugged spaces seem to speak to something in the American soul, a certain restlessness, a spirit of self-reliance. And while many still cherish the legends of the Old West, it is increasingly being replaced by something very different, the New West. Four-wheel drive vehicles and bulldozers are pushing steadily into what was once open range country. In the United States, the three largest deserts are the Mojave, the Sonoran, and the Chihuahuan. The Chihuahuan is a high desert, the largest in North America. It is also the location of the Jornada Experimental Range, dedicated to desert ecology and agricultural research. Chris Havstead is the supervisory scientist here and teaches at nearby New Mexico State University. He believes this desert is precious.
This is the most politically, culturally, socially, economically, and ecologically important and viable resource in the western United States. There's a large amount of the land surface of the world that's occupied by deserts like this one, and they're not barren. They're alive places that are very dynamic. What we realize when we get out and really look at those deserts is that they're teeming with life. In this range right here, there's maybe 500, 550 different plant species here. There are all sorts of raptors, birds of prey. There's all sorts of small animals. The soil itself is full of all sorts of life.
Unfortunately, man's intervention in the landscape has put much of that rich biodiversity at risk.
The aquatic ecosystem in the West, really throughout the West, from the Rocky Mountains on over to the Pacific, is in very great danger and in great decline. And that includes the fish, especially in the Southwest, and the frogs throughout the West. And there are something like 13 species in the West, and at least 11 of them have declined very severely.
Besides being an important part of the food chain, amphibians have a unique spot in nature, halfway between reptile and fish. Their permeable skin makes them acutely sensitive to environmental changes and valuable in biomedical research. Like canaries in a coal mine, they react to the same toxins as humans, only sooner. Frogs are in trouble all over the U.S., but the western frogs are most severely affected. One of those is the Chihuahuan leopard frog.
It's a great big pretty green frog. It's kind of a neat frog. And if you have any taste for frogs, it's pretty much Kermit.
I'd like to see it not be an endangered species, but just be a species you can go out anywhere and see in the area, you know, anytime during the rainy season.
Rancher Matt McGoffin grew up on this land and remembers seeing hundreds of Chihuahuan leopard frogs in local ponds. He saw an opportunity to restore a species and avoid the restrictions that come with endangered species status. When the ponds were drying up in 1993, he and his family rescued some 800 tadpoles and brought them to the nearby San Bernardino Refuge. When the entire refuge population disappeared, Matt and scientists like Phil Rosen realized the Chihuahuan was being gobbled up by a non-native species of bullfrog brought in from the east. Just like the rabbit in Australia, the bullfrog was wiping out native populations. So in 1994, McGoffin and local scientists tried again, this time introducing the Chihuahuan leopard tadpoles into separate enclosures to protect them from bullfrogs. To sustain the population through dry months on his own property, McGoffin began hauling water. Each trip took 3 hours. He and his family brought water to the frogs over a span of 3 years.
I figured it up, and we had hauled over 100,000 gallons of water to the frogs.
McGoffin enlisted the support of a local group of ranchers known as the MultiBorderlands Group.
They've been real supportive. They've helped in drilling one well and getting it equipped with a pump and a windmill, and that's saving one population of frogs there, the pond that they were in would have dried out, but with that well and windmill setup, it saved that population this year.
That investment convinced the Arizona Department of Game and Fish that McGoffin was serious. They helped him pay for a second well. The McGoffin family no longer needs to haul water, and the future of the Chihuahuan leopard frog is looking much brighter.
I consider them my friends that I need to protect, so long live the frogs!
Ranchers may seem unlikely environmental heroes. Here in the West, conservationists and ranchers have spent more time snarling at each other than cooperating. But the MultiBorderlands Group signals a new approach based on the realization that a ranching economy and a healthy ecology are not mutually exclusive. In fact, in a society where the value of land is determined by its productivity, this new alliance of conservationist and rancher is perhaps the only hope of preserving open spaces and the ranching way of life. Member ranchers, there are several dozen, including the McGoffins, agree to put a conservation easement on their property.
What it does is it says that you aren't going to subdivide your deeded land, and you won't use the deeded land for mining operations or toxic waste dump sites or whatever. It's just to maintain it as it is right now. If we don't do something soon, all the open spaces are going to disappear, and then everything will be endangered, including people, because there just won't be the space to grow food. All the good spots as far as for farming are being taken up and subdivided, and we don't want to see that as far as this is a good ranching area here.
Do we need to make a motion?
Oh yeah, we definitely have to make a motion. We're going to spend some money here if we do it.
Politically, this group occupies the radical center. One of their members is the Gray Ranch, a kind of working range preserve run by a non-profit foundation. The MultiBorderlands Group runs a grass bank, so members can spell their herds during drought. They cooperate with university scientists on experiments with controlled burning to clear unwanted brush and other methods of restoring beneficial grasslands.
Blue grama, snakeweed.
And I think
Scientists and conservationists welcome their help.
Ranchers can play a very positive environmental role, one that we can't very well play in an economical way without them.
Much of the landscape here has degraded. It's lost certain functions. And what we've learned from our research is that many of those functions won't be restored by simply walking away and letting time take its course. And it's probably not going to happen using tax dollars and a federal agency having enough people to address the land at the intensity level that's required. In other words, an individual working on specifically kind of a ranch level. You've got to have people gainfully employed, and probably self-employed, working on something that they have ownership in, that they've got some vested interest in, working at a scale where they're going to be effective.
The cooperative spirit, which comes so hard to independent ranchers in the US and Australia, was never a question in Israel. The Jews knew a joint effort would be the only way to carve a life out of the desert. Reclaiming the desert has long been a national and even international obsession for Israel. In the early 1900s, the Jewish National Fund had begun buying back pieces of their ancient homeland. In time, Jewish pioneers and refugees from all over the world came to carve a new life on kibbutzim, or collective farms, in the barren landscape. One of those was Yoel de Malach, who came to Palestine in 1943 at the age of 15. A Holocaust survivor who knew nothing about farming, let alone farming in the desert, Demalach nonetheless helped found one of the earliest outposts in the Negev desert, Kibbutz Revivim. He and his fellow pioneers literally started from scratch and learned to survive in the sand the hard way by trial and error.
We have no miracles, but different methods. And learning slowly, year after year, month after month, how to improve the conditions with the help of science. And this is a very good combination. Our knowledge is not enough, and we have to join the scientists to work together.
It has been a fruitful partnership. Over the years, the Israelis have been on the leading edge of arid agriculture worldwide. They learned to cope with the hot sand and salty water common to many arid lands. Yoel Demalach is credited with a major breakthrough: the adaptation of plant species to brackish or saline water. Jewish settlers tapped into this water supply by drilling wells deep under the desert. The Israelis were also early pioneers in drip irrigation. Its slow, near-continuous watering has replaced flood or sprinkler irrigation in many arid regions of the world. Because water is delivered right to the roots, very little is lost through evaporation. This method also prevents a buildup of salt, which could prove fatal to plants. With the proper technique, plants can thrive even on saline or brackish water, if you know the secret.
Not increasing the quantity, but maintaining the soil always wet. So if the soil is wet, there is no concentration of salt, because drops come again to dilute the soil solution. And this is the secret. If you ask about the secret, this is an open secret for all the world.
Bev Alpert and her husband Bruce are the next generation of desert pioneers in Israel. They moved here more than 25 years ago from Ohio with 2 small children to work on the Moshav, or cooperative farm. They stayed and had 2 more children, but the early years were hard.
Nothing, not a tree. There were no trees, a few bushes and this scrubby wheat that was trying to get by on whatever rainfall there was.
In the beginning, they raised tomatoes. Later, they switched to flowers, which find a lucrative market in the Netherlands. The Alperts say none of it would be possible without heavy government support.
As individuals, we never could have done this. To develop the desert properly the way that it's been done here takes a will on the part of governments and on the part of all kinds of research and scientific institutions. It can't be done by just a few people that want to make a nice life for themselves. There's just too much involved and too big a scale.
If life in the desert is life on the edge, it is water which defines the edge. When it comes to managing this crucial resource, the Israelis take nothing for granted.
We are using in Israel 100% of our water resources, which is the crazy thing. That means that if for 5, 6, 7 years we have drought years, we have finished the whole water. The Lake of Galilee will be empty and so on. So we are just playing with fire. This is one side. The other thing is that the population of Israel is growing. And we are today 5.5 million people. And we believe that in the year 2010, we'll be 8 million people. And we have to provide drinking water to all the population. That means that if you have to provide drinking water to the whole population, there's absolutely almost no water left of drinking water for agriculture.
By then, the Israelis hope to have developed economically viable technologies for the desalinization of seawater. In the meantime, water conservation is a high priority. Surface water that would otherwise flow to the sea is being captured, and wastewater is being recycled for agricultural use. Already you see color-coded pipes carrying salty water, purified wastewater, and sweet drinking water. Eventually, all water in Israel will be recycled. Reservoirs are being constructed to store the purified wastewater and capture winter floodwaters for use during the dry months. This project is on the Besor River.
Here we see combination of a water reservoir, the dam, and then a water reservoir, which can have about 1 million cubic meter of water.
Reservoir water is stored and used for agriculture. Today, flowers are Israel's principal export crop. Israel also supplies much of Europe with produce in the off-season, when the fruits and vegetables get premium prices. New reservoirs allow new orchards to be planted. Historically, trees have a special place in Israel. The tree of life, the tree of knowledge, of good and evil. It is written in the Bible that trees must be protected, even in times of war. According to ancient Hebrew custom, a tree is planted for the birth of every child, cedar for a boy, cypress for a girl. Since the creation of the Jewish state in 1948, more than 200 million trees have been planted, many of them in the northern part of the country. In the last decade, however, the focus has shifted to the more arid southern portion of the country. Because these areas in the northern Negev desert get less than 10 inches of rain a year, lush forests were not a realistic goal. The Israelis had to find a new approach that would be sustainable under drier conditions.
We are creating the first man-made savanna on the globe. Usually a savanna, it's either a deteriorated ecological system that goes from a forest or a tropical or subtropical forest going toward the desert, or it's a kind of an habitat with very low productivity.
The Israelis are trying to reverse that cycle, build desert back up to savanna. Menachem Sachs heads the Sevenization project, which began in 1986. So far, 8,000 acres have been restored to increased biological diversity and higher productivity.
We succeeded in creating patches of man-planted trees which are very similar to the natural patches that one finds in the area. The main idea is that if we will succeed in creating a natural patches, even though they are man-made, they will be sustainable.
Sevenization puts in motion a favorable chain of events. Planting trees anchors the soil and stops the erosion, which causes deserts to spread. That allows the growth of low shrubs and patches of grass, which in turn help trap surface runoff so that water percolates downward to the roots. Insects return, and then birds. Eventually, even grazing animals can be reintroduced. Production of fuel and fiber is increased, soil condition improved, and dust reduced. Aesthetic benefits are important as well. Green belts planted around cities in the desert provide a buffer zone, a more soothing landscape for the people who live there. Patches of green provide welcome relief and a setting for recreation. The entire chain depends on an integrated approach and careful management of water within a very large area.
We made a decision that we have to get involved with the watershed on one hand, and if possible, with the ecosystem as a whole. We control the run of the water, and instead of the water causing soil erosion, we are collecting the water within the watershed to irrigate the trees. Under the Sevenization project, they are getting double or even triple the amount of water per tree, and so they are able to develop.
Through a group known as the International Arid Lands Consortium, the Israelis are sharing their knowledge with scientists from other arid lands. Joint research funded by the consortium is providing much needed knowledge for arid land managers and policymakers. The goal? To stop desertification. For example, several projects now underway are helping scientists to better understand the cryptogram crust found on many arid soils. This crust is a network of microbes that serve as a kind of living mulch to hold sand down and seal moisture in or out.
So you've got this soil resource, and it's got a set of organisms that live right on the surface, and they provide the interaction between the air and the soil itself, and they have a tremendous influence over the ability of that soil to take in water. They have a tremendous influence over the nutrient dynamics, the ability of that soil to produce nitrogen.
Sometimes invisible, sometimes submerged beneath a layer of sand, the crust is highly vulnerable to trampling by four-wheel drive vehicles and herds of animals. Once destroyed, it's very difficult to restore. The crust is very complex and just a tiny piece of the big picture.
The thing that's particularly difficult to deal with in vast areas of land which vary a lot through time is understanding how much of the changes that take place are things which are caused by our management actions as opposed to things which are just part of the natural background.
Clear prop.
To help sort that out, Australian researchers have taken to the air with remote sensing equipment.
If you just come down and you look at 1 square metre on the ground, it's easy to work out how that's changing, but you don't know whether it's representative of what's going on over the vast areas. On the other hand, if you just go to the entire landscape and just get a picture from a satellite without any good interpretation, you don't know to what extent you're just reflecting background noise in the whole landscape. So the real challenge is to link between those two scales and actually be able to go from the square metre to the hectare to the square kilometre to perhaps 20 square kilometres to the whole landscape and be able to go back down again. And it's making those linkages across scales, which is so important here in Australia, but also valuable elsewhere, that a lot of our work is focused on.
The work is taking place here at the Centre for Arid Zone Research. It's being funded by the Commonwealth Science and Industry Research Organisation, more commonly called CSIRO.
With our past research, we've extracted information from the satellite data which gives us a good handle on what grazing effects have been, but when we've gone out to try and verify that on the ground, we've found it as a very complex and a very difficult task, a very labour-intensive task. Since we've been developing this video system, we've found it's a much more efficient way of just establishing a link between the satellite data and what's happening on the ground.
The camera's down the back of the aircraft, and it's right next to me so that I can keep control over it. And there's 2 monitors in the aircraft right behind the pilot seat and passenger seat.
The video camera captures still images of the landscape below from different altitudes and digitizes them. A satellite-based global positioning system, or GPS, gives a precise location for every frame so that it can be correlated with satellite photographs of the same area. On the ground, sophisticated software is used to process the images and enhance their value to scientists. The images of a single location can then be viewed from varying altitudes and over time to show what's actually happening in the ecosystem.
This image here is the same area, obviously, but after a very good rain. And this image shows the very dramatic way in which the vegetation has responded. It's a false colour composite image where areas of healthy vegetation and very actively growing vegetation are shown in the bright red. And the thing that's very apparent in this image is even though there's been a dramatic response, not all areas of the paddock have responded in a uniform manner.
Scaling up and down is a really major issue in ecology at the moment because we, as collectively as ecologists, have done so much work which is basically done on the ground in small areas, and we assume that we can simply take that and multiply it up. But it actually doesn't work that way, because when you look at whole landscapes, different parts of the landscape operate differently, they interact with each other. And so being able to have a technique like aerial videography which enables you to scale up from small areas to big areas and do it in a way which is truly comprehensive is actually a really major step forward.
And what if scientists had the ability to add a fourth dimension? What if they could move through space from the stars to the soil and then watch the land's evolution over the long term? That's exactly what USDA and New Mexico State University scientists are doing today, thanks to an incredible archive at the nearby Jornada Experimental Range. They call it the Laboratory Without Walls. It's run by the USDA's Agricultural Research Service and possesses a unique treasure: detailed observations of the desert made by USDA scientists over more than 8 decades. This information, once buried in old journals and Jornada archives, may now be the key link to understanding similar historical data from nearby university range research. There are hand-drawn maps and field notes scrawled in pen and pencil going back many decades.
We do tend to feel that everything's on computers these days, but a lot of information, very valuable information, is being collected before computers, and it is just on handwritten or typed format. So we have to electronically capture that, and it means scanning and re-entering a lot of that information.
Getting it all into the computer is a painstaking process. But for Bob Sanderson, a British scientist who came to New Mexico 13 years ago to study American deserts, it's also an incredible opportunity to identify the long-term trends masked by short-term changes.
Yeah, these are the old photographs. These are the 9x9s. Some of these may be black and white, but we might be able to go back all the way to 1940. Here's one.
Sanderson is heading up a demonstration project to compile and update this database and then visualize the result.
The next step, link that information both in time and in space. It's valuable information, but it becomes more valuable if we know when it was collected, where it was collected. And we need to register or georeference where those study sites were.
The demonstration project involves a native plant that competes with grasses, snakeweed.
For example, with snakeweed, there's several established study sites in New Mexico. We have gone out and with the global positioning system, surveying and mapping techniques, we've gone out and positioned those sites. We've located the study plots. In some cases, we've even gone and located in space individual plants. What did you say this file name was? Can you remember?
The PDOP is 3.8.
So this is the edge of the south well, on the edge of the concrete block. Our antenna is 8 feet, and our PDOP is 3.8.
They take similar satellite readings at landmarks like windmills, water tanks, and roads, which they cross-reference with historical aerial photographs.
So this is the study area that we just went and got the reference points for, the well and the tank. So that aerial photograph becomes linked to space. It's now known latitude, longitude of every point on that photograph.
Sanderson takes the data to the Physical Science Lab at New Mexico State University, where he hopes to transform decades of scientific data into computer visualization, similar to this USDA plot animation.
The studies that are done give us information. I mean, it may be a grazing study, and that if you graze this intensity, this is what's going to happen to your snakeweed, or this is what's going to happen to your grass. We can then use our model to say, all right, let's apply that grazing model to this landscape scale, and then we'll recreate that landscape and say, well, this is what your landscape will look like in 40 years if you graze at this level. Or if we have a drought, this is what it will look like. But the ultimate goal is to develop models for us to better understand our environment and to manage our resources.
When you're dealing with deserts, you're dealing with catastrophic kinds of environments. Things don't happen here on a constant, steady, kind of chronic level. Things happen here in a very acute fashion. More specifically, what we've learned here is that these landscapes are very dynamic, and that when they change, and they do change, and they have changed not only in terms of geologic time. The area where we are sitting 40,000 years ago was a lot more conifer trees, and I mean, it was vegetatively, it was very different. But they've also changed just in terms of human generation time. And that with those changes and movements into new kinds of states, that it is not very likely at all that they will go back to prior states. And that is really a significant change in our thinking about the ecology of landscapes.
It has also become clear that the land does not distinguish between changes wrought by human presence and those caused by acts of nature. For good or ill, man is part of the desert equation. Simply withdrawing fixes nothing, and in fact may result in worsening conditions.
Our idea is that man is part of the desert, and by managing it not in the right way, you cause the desert to expand. There is nothing wrong about desert. The problem is when a fertile land goes into desert, moves into desert. This is what we want to prevent on one side, and in places where this happened in the last couple of hundreds of years, we want to try to reverse it.
Scientists are learning, slowly, to understand the dynamics of arid ecologies so that they can harness nature's own processes to halt desertification and restore the land.
Everything that we do, we try to do it in the best way that disturb the minimum and to get the maximum.
Wise management of arid lands requires an intimate knowledge of each region's particular characteristics. To be successful and sustainable over the long term, solutions must be locally appropriate, ecologically sound, and economically feasible.
We have to get away from simply thinking that we are trying to improve productivity at all costs to starting to think much more about how to integrate all sorts of different land uses. And that means we have to be able to understand far better what the impact of one land use on other land uses might be. I think the critical thing that research will provide is better information for making these decisions.
The race to acquire that information is on. What society does with this knowledge remains to be seen. The course we choose determines our ability to be survivors in the sand.
Out here the blue sky goes down to your boots. The endless fence line never reached the horizon. I need this space to be wrapped around me. Give me all these things, I will survive. Give me all these things, I will survive.
The preceding was a production of New Mexico State University. The views and opinions in this program are those of the author and do not necessarily represent the views and opinions of the NMSU Board of Regents.